There is only silence in space, right? That's what we all been told. No air, no sound, no noise, just a cold, quiet void. But here is the thing. While sound can't travel through the vacuum of space the way it does on Earth, that doesn't mean the universe is silent. Not even close. What you're about to hear are real signals, recorded by spacecraft, translated from electromagnetic waves, plasma oscillations, and radiation pulses into something we can actually hear. They are not fake, they are not sci-fi. These are the voices of planets, stars, black holes, and the void itself. NASA and other space agencies have turned raw data into sound using a technique called sonification. And the result? Honestly, it's unsettling. Because when you listen to these recordings, you don't just feel like you're hearing the universe, you feel like the universe is screaming back at you. In this video, we are diving into the creepiest, most haunting sounds ever recorded in space. From the whispers of Saturn's rings to the eerie howls of a black hole. You're about to find out. Space may be empty, but it is not quiet. Before we dive into the cosmic audio itself, there is one thing we need to clear up. Because yes, space is a vacuum, and technically sound can't travel through it. On Earth, sound moves through air by vibrating particles. But in space, no air, no molecules, no vibration, at least not in the way that we experience it here. So how are we hearing anything at all? The answer is fascinating. Instead of recording sound waves, many instruments detect electromagnetic waves, radio signals, plasma vibrations, and magnetic fluctuations. These aren't sounds in the traditional sense, but they can be converted into audio through sonification. Think of it like this. Scientists take raw data, oscillations in charged particles, frequency spikes or radio bursts, and scale them into human hearing range, often adding time compression or pitch shifting to reveal patterns that are otherwise invisible. The result isn't artificial, it's a translation of space's natural rhythm. Some of these sounds come from the interactions between solar winds and magnetic fields, others from planetary auroras, and a few from places like the edge of interstellar space or even the event horizon of a black hole. These sonic conversions are more than just eerie. They are tools. They help scientists study space environments in entirely new ways. And for us, they make the unknowable feel tangible. Something we can hear, feel, and react to. And let's be honest, some of them sounds are downright terrifying. Stick around because what you are about to hear will make you question just how empty space really is. Like what you're hearing so far? Hit that like button, subscribe, and drop a comment telling us which sound creep you out the most. When the Cassini spacecraft arrived at Saturn, scientists expected to capture stunning visuals, and it delivered. But what they didn't expect was the sound. As Cassini passed through the gap between Saturn and its innermost rings in 2017, it used an instrument called the Radio and Plasma Wave Science Detector to pick up electromagnetic waves. Those waves were then converted into audio frequencies we could hear. What they got was nothing short of unsettling. It wasn't a peaceful hum. It wasn't the gentle whir of space dust. It was crackling, popping, almost like static, interrupted by sharp bursts, irregular pulses, and the eerie hiss of something alive and mechanical. One scientist even described it as sounding like an alien transmission. So what caused it? Saturn's rings may look smooth and solid from afar, but they are made of countless particles, ranging from dust grains to boulders, colliding, vibrating, and interacting with charged particles in planet's intense magnetic field. Cassini picked up plasma oscillations caused by those interactions, especially where solar wind meets Saturn's magnetosphere. It's science, but it sounds like something from a horror movie. And the most chilling part? During one of its closest passes, Cassini expected to hear a lot more activity in the gap, but instead it found near silence between bursts, almost as if something was missing or hiding. The sound of Saturn's rings reminds us that space isn't just beautiful, it's alien. Even the familiar worlds in our solar system can surprise us with behaviors and environments that feel completely otherworldly. And if Saturn whispers, Jupiter roars. When NASA's Juno spacecraft approached Jupiter in 2016, it wasn't just there to take pictures. It carried instruments capable of detecting powerful bursts of electromagnetic activity around the gas giant. And what it recorded sounded like something out of a nightmare. Juno flew through Jupiter's intense auroral regions, zones where charged particles slam into the upper atmosphere near the planet's poles, much like Earth's auroras. But Jupiter's version, it's on another level. The audio from these regions is a deep, growly screech laced with sharp, crackling bursts that almost sound alive. It's as if the planet is growling, an electric howl echoing across space. These auroral sounds are caused by powerful magnetic fields accelerating particles to extreme speeds. Jupiter has the strongest magnetic field of any planet in the solar system, 14 times stronger than Earth's. That means it traps and flings particles with enormous energy, generating intense plasma waves that ripple through space. When Juno crossed these regions, it picked up bursts of energy that made even seasoned scientists stop and listen. This wasn't static. This wasn't background noise. It was the planet itself, raging with power. Jupiter's roar isn't just eerie, it's also valuable. By studying it, scientists gain insights into the space weather, planetary magnetospheres, and how solar wind interacts with distant worlds. But for us, it's a reminder that these gas giants are far from silent giants. They are dynamic, volatile, and sometimes they sound like monsters in the dark. If you thought that Saturn's crackles and Jupiter's roar were unsettling, wait until you hear a black hole scream. In 2003, NASA's Chandra X-ray Observatory was studying Perseus Cluster, a massive collection of galaxies over 240 million light-years away. What it found was extraordinary. Waves of pressure rippling through hot gas surrounding the cluster's supermassive black hole. These weren't explosions or jets, they were sound waves. Real ones. Low-frequency waves traveling through clouds of superheated gas. Vibrations so deep and slow they translated to a note that was 57 octaves below the middle C. In other words, a pitch far too low for human ears to detect. Until scientists did something brilliant. They sonified the data, scaling the frequencies up into audible range. What they produced sounds like a cosmic moan, deep and distant, with an unnatural pressure behind it. It's haunting. It's massive. It's like the universe itself is groaning. This isn't fiction. This is a real black hole generating sound as it pulls matter inward and disturbs the gas around it. What's even more chilling is the size of the structure behind this. The waves it produced stretch across tens of thousands of light years, rippling out like the blast from a cosmic speaker. If your ears could detect it, you'd be hearing this black hole's hum even now, from across space and time. So, can black holes scream? Not exactly, but they can produce something far more alien, the slow, thunderous echo of gravity itself. And this isn't even the only time we've heard the cosmos hum back. On August 25, 2012, something incredible happened. Voyager 1, the little spacecraft launched in 1977, crossed the boundary of the solar system, becoming the first human-made object to enter interstellar space. But it didn't just float silently into the void. It brought back a sound, and it was eerie. Using its plasma wave subsystem, Voyager 1 picked up electromagnetic vibrations in the charged particles of space. As it moved beyond the heliopause, the invisible bubble where the sun's solar wind ends, those particles changed. Suddenly, space began to hum. NASA converted these plasma wave readings into audio frequencies we could hear. What came back was a high-pitched, ghostly tone, faint, rising, and oddly organic. It's the sound of interstellar space itself, a quiet but persistent whistle that pulses as Voyager moves through different regions of density. And it's not constant. Sometimes it goes silent for months, then out of nowhere the pitch spikes like a warning from deep space. What's causing it? These changes likely reflect variations in plasma density between different interstellar regions, evidence of just how dynamic and alive the space beyond our solar system really is. But there is something deeply emotional about it too. This isn't just a machine sending back data. It's a 46-year-old spacecraft powered by a decaying nuclear battery billions of kilometers from Earth, floating in eternal night, still whispering back to us, a single voice in the void, still calling home. And that sound, gentle as it is, might be the loneliest sound ever recorded. But not all space sounds are soft. Some pulse, some pound, and some throb with terrifying rhythmic power. Stars don't just shine. Some of them also sing. Well, kinda. Take pulsars for example. These are the dense, rapidly spinning remnants of massive stars that exploded in supernovae. What's left behind is a neutron star, a city-sized sphere of matter so dense that just a teaspoon of it would weigh billions of tons. But here is what makes them truly strange. Pulsars emit beams of electromagnetic radiation from their magnetic poles. As they spin, those beams sweep across space like a lighthouse. And if Earth happens to lie in their path, we hear them as precise rhythmic pulses, clicks, beeps, or mechanical ticks depending on the frequency. One of the fastest ever recorded? PSR J1748 2446 AD, spinning over 700 times per second. And if you listen to the sonified data, it sounds like a perfectly timed beat, so precise it was once mistaken for alien communication. Warning for headphone users. But it's not just distant neutron stars that pulse. Even our own sun rings like a bell. Its surface ripples with oscillations, caused by sound waves bouncing around inside the sun's interior. NASA's sonifications of solar vibrations reveal deep, rolling tones almost like the rumble of a cosmic drum. It's a reminder that stars aren't static. They breathe, vibrate, and sing in a language written in light and plasma. And while these sounds may not have a meaning in traditional sense, they hint at something deeper. That the universe isn't just a place, it's a symphony still playing. For something that's supposed to be silent, space has a lot to say. From the haunting crackle of Saturn's rings, to Jupiter's electromagnetic shrieks, to the deep rumble of a black hole's gravity waves, the universe isn't quiet. It's alive with motion, energy, and rhythm. We don't hear these sounds with our ears, we hear them through data, through instruments, through translation. But what we are listening to is real. It's not sci-fi, it's not artificial, it's the universe speaking in its own language. And what makes these sounds so powerful isn't just how strange or eerie they are. It's that they connect us to places we may never visit. When we hear the pulse of a pulsar or the song of the solar wind, we are not just receiving data. We are experiencing the heartbeat of the cosmos. These sounds remind us that we are part of something much bigger, something ancient, something that moves, breathes, and pulses across billions of light years. The next time someone tells you space is silent, remember this. It's only silent if you don't know how to listen. Thank you for watching. Keep looking up.